we are going to continue in our journey on programming. This is what I call level 2, Foundations in Programming. We're talking about loops. That's what we're here to talk about, loops. All right. We're going to talk about a couple of different things. We're going to give an overview of loops. We're going to talk about for loops, and we're going to talk about while loops. So let's do a quick overview of what we mean by loops. If you've done some programming elsewhere, you probably have heard of these. Maybe you're here because you're looking for a refresher, or maybe you're brand new, in which case, welcome to the first day of the rest of your life. Loops are ways to execute repeating or looping lines of code. So far, we have executed code line by line from top to bottom. So we've said, for example, in the previous video on functions, we said define triple x, return 3x, triple 4. And we've gone from top to bottom. We've gone from top to bottom importing data. But sometimes we may want to run the same line of code or lines of code multiple times. Loops allow us to do this. If you're wondering, how am I going to remember loops and what they do? All you have to do is think about the classic Britney Spears hit, Loops. I did it again. Oh, thank you so much. Oh, Britney, I hope you're okay. All right, here she is demonstrating exactly what our code is going to do when we write loops. So just think about that and you'll be home free. All right, so a for loop is one type of loop, and this is a loop that iterates over a sequence a given number of times. So the way we're going to write it is for iterating variable in some sequence, colon, do something. That's the formula we're going to work with. So we use for loops when we know the number of iterations that we want. For everything in my list, for numbers 1 through 10, go ahead and do this thing. Typically, this will be over a sequence. Up next, we're going to use while loops. And the main distinction here is that these are useful when we don't exactly know how many iterations we want, but we want it to iterate until we hit some value or something else, some other threshold is crossed. Let's get into some examples. So here I've written my list in square brackets, contains elements 1, 2, 3, 4. My for loop is for I, so each element in my list, print I. Lo and behold, I'm printing 1, 2, 3, 4. This is the simplest list I can muster. I suppose I could put fewer elements. We can do it again. We don't need to use the letter I. We can say something else. So for example, X. In this case, my list equals 1, 2, 3, 4 again. For X in my list, print X. Same outcome. I can also call it something else, right? So I don't have to say my list. I could say prices or ages or heights or years or whatever it is that I want. For X in prices, ages, years, whatever, print X. There I go. So another way to think about for loops is visually. So we have our code running in our program. It's running from top to bottom. We're doing this, we're doing this, we're doing this. And then we're going to hit our for loop and we're going to say, computer, aha, for. So all of a sudden the computer knows that we're in a for loop. For some condition, numbers 1 through 10, for everything in my list, for whatever the condition is that I want. If that condition is still met, so we're still working through the elements in a sequence that we've provided or a range from 1 through 10. If that condition is still holding, then go on back and do all this again. So go on back, do this sort of thing, and keep doing that thing until the condition is false. Once it's false, exit the loop and keep going. So a couple more examples here. So again, that's our overall formula. We saw last time with list, we can do it with an array. So I'm using a NumPy array here. I've created my array, contains 3, 5, 7, 9. For X in my array, print X. And as long as we have an X in my array, the computer will keep iterating and do that command, which is print X. And once I've gone through each element, the condition is now false, and I continue on. A very useful technique with for loops is something called a range. Ranges are also useful outside of loops, but they're really, I think, most intuitive in the context of loops, so we put them here. A range is super useful here and beyond. The way we're going to write a for loop using a range is for iterating variable I, X, whatever, in range, and then we're going to contain information that could include up to 3 things. We're going to say start, stop, and interval of our range. Do something. So let's make that concrete. We might write code like these. We'll go through each one at a time. So the first one, for I in range 10, print I. We see that we get the values 0 through 9. This is because when we just put one argument in range, it defaults to the stop. So it's going to start automatically with 0. It's going to go by default by 1, and it's going to end before, not inclusive of, the stop. So if you write I in range 10, print I, you will get the numbers 0 through 9. And please do try this out on your own and see for yourself. If I do want to actually print up to 10, I'll need to write for I in range 11. So the end is not inclusive, but just putting one number does define the end. If I put two numbers in here, two arguments for I in range 2, 10, we are going to get numbers 2 through 9, because when we have one number, we indicate just the stop, but when we have two, we are indicating the start and the stop. And finally, the third argument is the interval. So if I write for I in range 2, 10, 2, pause the video and guess what's going to happen, or see for yourself in your own code. Yes, we get 2, 4, 6, 8. So start, stop, and interval. This might seem sort of trivial and silly here, but having this in your back pocket is going to save you some grief later when you're doing your own coding, as well as when you're reading other code on the internet. As I said, you can use ranges elsewhere or on their own. It's basically just a sequence we can automate. We're using NumPy ranges. So NumPy to the rescue again. I can just simply create a range that starts at 5, ends at 20 non-inclusive, and goes by 2. So I get 5, 7, 9, da, 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 da. And we can also create a range without naming it. I can just write out my range. So test yourself. What will this particular line of code generate? You got it. The numbers 5, 6, 7, 8, all the way up to 19. And what about this one? That's right, 0 through 19. Very good. All right, so we got ranges. While loops. So a while loop means we repeat a block of code until a condition is false. This sounds almost identical to a for loop. Let me break it down. So the way we're going to write a while loop is we're going to say while expression, do something. Fantastic. So we're executing a block of code over and over and over again until a given condition is false. Unlike for loops, where we specify the endpoint from the range 0 through 10, that's a for loop. A while loop is useful when we don't know how many iterations we want, but we want to go until some condition is met. So here are some examples. I'm going to set x equal to 0, and I'm going to say, hey, computer, while x is less than 10, print x, and then carry out x equals x plus 1. So that's going to result in 0 through 9. We can break it down what's happening here. So x equals 0. All right. While x is less than 10, so x is 0, so x is less than 10. So that's true. Print x. Okay, I've printed x, which is 0. And then add 1 to x. And now it's 1. So I'm going to print 1. And then add it to x. It's 2. I'm going to print 2. All the way up until 9, at which point we'll hit the while expression and we'll say, oh, it's not less than 10 because it is 10. And it will exit the while loop. Again, I'm just doing tiny little tweaks here so you can get a feel for it. Set x equal to 5, same while loop underneath, and we just get the numbers 5 through 9. We can change it another way. X is 0 again. Now we're going to say, well, x is less than or equal to 10. The rest of the loop is the same. We get our number 10. Again, these are simple. Try them on your own. Make sure it's second nature as you are working through these. Okay, try this one. X is 0. While x is equivalent to 10, print x. And then add 1 to x. What are we going to get? In this case, you are right, nothing at all. We're going to get nothing at all because x is never going to be equivalent to 10 if x is 0, so we don't even enter the loop. All right, here's another one. X equals 0. While x is equivalent to 0, print x, and then add 1, and we get a 0. Wonderful. We can also make it slightly more complicated and print something a little bit more interesting. And in this case, we have said, okay, while x is less than 5, print the value of x is, and then as you exit, print the end. What a lovely little poem we wrote. So to visualize, we have our code. Our code is running. We're running down, and then the computer hits our while loop, and we provide some condition. X is less than 10, x is greater than 2, whatever. If that condition is true, x is less than 10, then carry out the command that I have provided in my conditional code. Print x, add 1. Or whatever. And then I'm going to hit the while loop again. And as long as that condition is still true, I'll do it again. The minute that condition is false, I exit and I keep going. So very similar. Nested loops are next level fun. So a nested loop is when we run one loop inside of another. These are, in theory, straightforward. They always break my brain, if I'm honest, when I look at them in practice. So for example, I could write for I in range 1, 10. For j in range 1, 2, print I plus j. Try this one out on your own. Pause this video, think about what you're going to get, see what you get. Aha. So we get 2, 3, 4, 5, 6, 7. Okay. What's going on in this particular one? Well, okay. So for I in range 1, comma 10. So starting at 1. For j in range 1, comma 2, also starting at 1, print I plus j. So print 2. Okay. Next, we go for I in range 1, comma 10. So we have number 2. For j in range 1, comma 2, 1. Print I plus j, 3. I sound insane. You get it. We can get more complicated. We can say I equals 2. Well, I is less than 10. J equals 2, etc., etc., etc. This is much more complicated. Feel free to work through it on your own. I won't try to read it out loud. We've created a nested loop plus some other language in here in order to evaluate whether or not something is prime. So a way to think about nested loops is a dream within a dream, a loop within a loop. If you're thinking of Inception, you are exactly on the right track. So that is how we think of our nested loops. Some of these statements you may encounter. Break is if you want to stop performing these steps before a loop completes. And continue is reject all remaining statements in the current iteration and go back to the top of the loop. Purists will tell you don't use those. You should be able to write your loops in a way that you don't need those lines of code, but I say do what you need for our purposes. Okay. All right. Now we're going to have some fun. You thought nested loops were fun. Wait till we see infinite loops. Infinite loops are when we often, but not always, accidentally create a while loop with a condition that can never be met. So the while loop is never false. This is awesome. All right. So for example, if I type x equals 0, while x is less than 10, print x, I will simply get zeros and it will simply scroll and scroll and scroll and scroll and scroll and scroll and scroll until I go in and stop the program. If you're using a Jupyter notebook, you can click the little stop button. Otherwise, it will go for a very long time. Here's another example. X equals 1. Well, x is greater than 0. Print x and then add 1. Hey, 1, 2, 3, 4, 5, 6, 7, all the way. So an infinite loop is exactly what it sounds like. It goes forever and ever and ever and ever, and it never stops. A reason you might want to do it on purpose is if you perhaps don't want your computer to go to sleep, you just write a little while loop and it will run and run and run and run and run. I don't totally recommend it as a first choice to do that, but you can do them on purpose, and there are cases where you'd want to. But generally speaking, most infinite loops I write are by accident, but they're kind of a fun accident, right? Right. All right. That's it for loops. We will see you next time with conditional statements.